Welcome back. We are going to start our factoring portion of polynomials in Chapter 7, starting with taking out greatest common factors. What is a greatest common factor? It's the largest term each expression can be reduced by. We're used to doing greatest common factors for just numbers, like 4 and 12. Now we're going to add letters into that, of course. So we'll include those in our examples. Greatest common factor of each of the following. So when we're looking at just numbers, for me, sometimes I like to just list number pairs. So what can make 18? Well, we have 18 and 1, 9 and 2, 6 and 3. What can we multiply to make 24? Or the factors of 24? 12 and 2, 8 and 3, 6 and 4. So we want the biggest number. 1, they both have. But 2 is bigger than 1. 3 is bigger than 2. 6, though, is the biggest. So our greatest common factor would be 6 for 18 and 24. 732 and 246. Well, these are huge numbers, but that's okay. I'm going to start just dividing in my calculator and see what we can get. 732 is an even number, so we know we can divide by 2, and that would give us 366. I can divide by 4 and get 183. Maybe I can divide by 6. Let's try that. 6 and 122. Let's try that one. 6 and 122. So 246. If I look at that, I know I can do 2 times 123. I can't do 4. Can't do 5. It doesn't end in a 5 or a 0. Let's see if I can divide by 6. That's 41. So it looks like 6 is again going to be our greatest common factor for those two. All right, now we're coming into letters. And we'll find that usually the greatest common factor is the smallest exponent. So I have 5 D's for D to the 5th and 3 D's for D to the 3rd. 1, 2, 1, 2. So I can match up 3 of them. And so D to the 3rd would be that greatest common factor. M to the 7th. N to the 3rd. And then we have M to the 4th. And N to the 3rd. So if I take a look again just at what I can match up, here's an M, and an M, and an M, and an M, N, N, N. So you can see I have 4 M's, which was the smaller of the two for our M's, the smaller exponent. And then the N's have a matching exponent. So our greatest common factor would be M to the 4th, N to the 3rd. Now, if we put it all together and we look at this last one, we have numbers and letters. Well, if I start with the numbers, I'll start with 48. 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. 36, we have 1 and 36, 2 and 18, 3 and 12, and 4 and 9. Then we have 2 W's, and then 9, and so if we take a look in there, looks like my biggest number is 12. And then the most W's I can match is 2, which again is that smaller exponent of the two variables. So that would make the GCF for that 12 W squared. Pause the video, try the try 1, 2, and 3. Come back when you're ready. So what is factoring? Well, factoring is writing a polynomial as a product of factors. Basically, if before what we were working on in the first part of our unit, we said, well, if I had W plus 6 times W minus 2, and we multiplied, we got W squared minus 2W plus 6W minus 12. And here's our common terms. So negative 2 plus 6 is 4. And we got this answer. We multiplied and got an answer. Well, when we're factoring, we're going exactly backwards. They are giving us the answer, and we have to find out what did they multiply together to get that answer. So that's what we're going to be working on as we're talking about factoring. Let's start with the process of just taking out common factors. Take a minute to jot these down, pause the video. So let's practice this. I'm going to start always with my numbers. There's a 1 in front of that x. 1, 4, and 5. Our greatest common factor of 1, 4, and 5 is just 1. And when I divide anything by 1, it's not really reducing anything. For our x's, I have 3 x's, 2 x's, and 1 x. So the most they all have in common is a single x. So we're dividing. And I'm going to write that common factor that we're dividing by outside a set of parentheses. Inside, we're going to write the remaining factors or the leftovers. Remember, when we divide with exponents, we're subtracting. So 3 minus 1 is 2, so that's x squared. We have minus 4, so we haven't changed that. There's just a 1. 4 divided by 1 is 4. 2 minus 1 for the exponents is x to the first. And then 5 divided by 1 is 5, and these x to the first simplify out because 1 minus 1 is 0. And so this is just taking out a greatest common factor. This is not finished, but for today, all we're doing is taking out a greatest common factor. Let's take a look at letter G. We again have a 1 here, so if I'm looking at the numbers 1, 7, and 10. Well, 7's a prime number, and I can divide all of it by 1, but it doesn't reduce any of those numbers. 3x's, 2x's, 1x. So again, the biggest number or variable that I have in common is x to the first. So we're dividing by 1x to the first. I'm going to put that on the outside of a set of parentheses as my common factor. So that's the, oh, that was terrible. Let me try that again. This is our GCF, and these are the leftovers. This is our GCF, our leftovers. Third power over first power, 3 minus 1 is 2. We still have minus 7 divided by 1 is 7. Squared minus first power is first power. Plus 10 divided by 1 is 10. First power over first power adds to 0, and there's no x there. And these are the leftovers. If I look at letter H, I'm going to start with my numbers. 2, 12, and 32 have a common factor of 2. For my x's, I have x to the fourth, x to the third, and x squared. So x squared is our smallest exponent and the most that we can pull out of all of this. So we're dividing everything by 2x squared. This is our GCF. 2 divided by 2 is 1. X to the fourth over x squared, 4 minus 2 is 2. We have plus. 12 divided by 2 is 6. X to the third over x squared, 3 minus 2 is 1. Minus 32 divided by 2 is 16. And squared over squared is 0, because 2 minus 2 is 0, so there's no x. So this is reduced form with the greatest common factor. Let's take a look at letter I. We have 3, 21, and 18, and they're all negative. So my common factor there would be negative 3. For my variables, I have x squared and x, but there's no x over here after the 18. So I can't take out a variable this time. All I can take out is that negative 3. So we're dividing by negative 3. Negative 3 divided by negative 3 is positive 1. And we have that x squared because we haven't reduced any variables. Negative 21 divided by negative 3 is positive 7. We have that x. And then negative 18 divided by negative 3 is positive 6. There is our greatest common factor and our leftovers. If you would please try the U-Tries. I'll see you in class. Have a great rest of your day.